Welcome back, everyone. It's time for our first project in the course. And the way that the course is structured is that the projects are not essential. There is no, important information baked into the project specifically as far as how the APIs work, how the models work, the different parameters. I kind of move that all out into their own videos. So if you don't care about the projects, you don't have to go through these. Because projects take a little bit of time, right? We have the prompting, we have the API calls and all of that, but then we have to build, in this case, a server and a front end and some JavaScript, some CSS, which a lot of you may not care about. So for all of these projects, I'm trying to make them standalone so that, after this project, we're going to learn more about the completion API, some different parameters, and then we'll have a project again. And then we'll learn about the ChatGPT API, and then we'll have a project, instead of just baking it all into the projects and forcing you to do the projects in order to learn everything in the course. So with that said, this is our first project. It uses the completion API, and it is a color palette generating website. So there's a server I wrote in Flask. We've got a front end here, very simple. And I put in some sort of prompt that I want it to generate a color palette based upon for me. So maybe Google brand colors. And then it hits our server and makes a request, sends us back the colors, and we render the colors here as these big, full height color bars. And not only that, we can see the hexadecimal codes, and I can click, and I've now copied that code. So a little bit of JavaScript to add it to our clipboard and make it somewhat useful. So if I really wanted to know, Airbnb brand colors, it's not just for brand colors, to be clear. There we go. I've now got the Airbnb red that I have access to. But I can also do things that are a bit more abstract, like Monet's water lilies, or the most boring colors possible. And we get a beautiful grayscale palette. Here's a different example. Palm Springs Hotel. So Palm Springs is a desert city in California, dry, orangey sunset tones, and that's exactly what we get. Or maybe I'll do, 4 colors for a hip tech startup website. And let's see what it gives us. Okay, so we've got 4, I guess, what are hip colors. You can decide if you agree or not. And that's pretty much all there is to the project. Why don't we try one more? Neon sign at night. See if we like that. It's okay. How about with dark sky? All right. Yeah, that's kind of neon signy. We got a dark sky color. I wouldn't say those colors look particularly nice. So why don't we try, pastel color palette. And then we can even specify we want 4 colors. And we get 4 pastels. Why don't we try one more? The colors of organic eggshells. And my chickens have sort of light green, light blue, light brown, light pink. Yeah, basically like this. I've now got the colors of my chicken's eggs. Okay, so in the next video, we'll start building this. And the way that we're going to do this is we'll begin with the prompt. That's the most important part, the most relevant to the course. We'll build that in a notebook. We'll get the colors just rendering in the notebook. And then we'll worry about building a server and all of that for those of you who care and want to build it with me. Okay, so let's get to work on the color palette generator project. As I mentioned in the previous video, we're going to start just in a notebook. I'm going to get this to work as far as the prompt goes, and we'll get some colors back, make sure we get the right format, write the right prompt, maybe give it some examples. And then in a separate video, we'll start on the server and all the infrastructure, everything that is not related necessarily to the completion API call. Here's one more palette I generated. An orange goldfish in a blue fishbowl. Kind of seems goldfishy and watery. Looks good to me. So what we're going to do is I'm going to start by just creating a new notebook. Maybe I'll duplicate one of the existing ones just so I don't have to rewrite everything from scratch. So I'll select one and click duplicate. And then I'll delete a lot of the stuff in there. And I'll rename this when it opens to be color palette generator. Okay, So I'm going to keep the import OpenAI. I'm going to keep the from.env import .env values. Remember, I have a .env file in this folder with my API key. If you don't, just put your API key right here, but then you don't want to share that code publicly because people will have your API key. And then I'll get rid of everything else in here. So we don't need that cell, whoops, or that one. And I guess I'll keep this one for now. Okay, so our basic prompt will be something like this. I'll do it up here, just in a variable. Generate me, we'll probably do something like you are a color palette generating bot or something like that. Assistant maybe. That responds to text prompts. So we're just giving it some instructions, right? For color palettes. And if we just left it like this and then gave it some text like a beautiful, beautiful sunset, let's see what it would give us. So I'm going to put my prompt variable in right here. I don't want that. And we're starting with Text DaVinci 3. I'm going to rewrite this project with GPT 3.5 and 4, but we're going to have to learn about the chat API in order to do that. So for now, this is the best we can do, and it works fine. This is right. What you're seeing here is with DaVinci 03. And I'll get rid of the stop point. And then why don't we print, well, let's just see what we get back first before I even put it in a variable. And what's our problem here? No key provided. I guess I never ran that line. And now we wait. Okay, so you can see the format it gave us here. It actually did use hex codes by default. The first time I was running this and building it myself, it gave me RGB colors and named colors, which it's kind of doing here too. Deep orange, salmon, sky blue, golden yellow, mauve. I don't know. So it's giving us some of what I want, but I'm going to get more specific and tell it I want it just to give me a JSON array of hexadecimal colors. So, desired format, a JSON array of hexadecimal color codes. And let's see how that does for us. Okay. So if we look in here, it is a JSON array of hexadecimal color codes. That's looking good to me. Let's go ahead and now save this into a variable. And this way we'll just print response. And then we want choices. And then 0, because there's only one choice in there. And then finally text. And there's our JSON array. Oh, this time it actually called it JSON array. So I don't want that, right? I only want this JSON array that's going to make it a lot easier for my code that is then going to do something with all these color codes, right? It's going to send it to the front end. It's going to respond so that we can then render each color. So it's going to be a little annoying if I have the text JSON array in the way. I just want to take this and parse it as Python and turn it into a Python list. So what I'm going to do is actually give it, there's many ways of achieving this. I could just say, results immediately after, and hopefully it's smart enough to figure that out. It is, and there we are. There's a couple of additional considerations I want to add in. First of all, I'm not telling it how many colors, and I'm okay with that. If you look here, this is giving me 4 colors, but then I can also ask for how about bright, bold colors. And it gave me 5 colors. And some of the answers might actually give me 8 colors. It's up to us. But what I did in my original prompt was I told it between 2 and 8 colors. So I'm going to give it some additional instructions. You should generate color palettes that fit the theme, mood, or instructions in the prompt. The palettes should be between 2 and 6 we can decide on 8. That's what I did originally. We might think it's too many though, but let's go with 8 for now. 2 and 8 colors. So that's the first thing I might want to tweak. Okay, so this one gave me 3, 4, 5, 6, 7, 8. That's fine. Let's try it again. Is it always going to default to 8? It looks like it just keeps giving me 8. So now what I want to do, I think, is provide it some examples of color palettes that I like. So what we called the few shot approach, where I showed an example, and I'll do it using this format, maybe question or colors or prompt, and then I'll have answer or result. So I'll probably just do Q&A. That's pretty common. So instead of making you watch me type out all these colors, this is an example from my original prompt I wrote. So it says, convert the following verbal description of a color palette into a list of colors. The Mediterranean Sea is the prompt. And then these are 5 colors that I found. I think I just found a color palette online that I thought looked good with, I think it was called Mediterranean Sea or something like that. So here's another example. This is a prompt asking for sage, nature, and earth. And then these are the 4 colors. They're sort of green, earthy, beige tones. And I encourage you to experiment, put in your own colors, write your own descriptions. I'm just providing a few examples to sort of show roughly what I'd like it to do. And let's just make sure it still works. And it gives me back a JSON list of color codes. There we are. And this prompt was a beautiful sunset. And it might just be a fluke. It's now giving me 6 instead of 8. I'd like to think my examples help to illustrate that we don't have to have 8. But it's, it's non-deterministic. We'll get a different result pretty much every time. So who knows if my examples are even doing anything. But I think it's useful at the very least just to give an indicator of the type of language it should expect. Sometimes more specific, sometimes very broad thing like the Mediterranean Sea, and then show it exactly what sort of format we want back. Now, what makes this hard at the moment is I don't know what this color looks like, or this one, or this one, or this one. So in the next video, we're going to work on just getting the colors to render directly in a notebook. It has absolutely nothing to do with OpenAI or any of our completion APIs. It's just something that will help us look at the results as humans and understand them. So we'll stop here for now. I'll be back in the next video. Okay, so the next step here is just a helper function that will take some colors and display them for us to see in a notebook, because it's really hard to know what colors these are and if our prompt is doing a good job or not. So in order to do this, again, it has nothing to do with OpenAI at all. We're going to write a function that can take a list of colors and then render each color in a notebook. And the way that we'll do that is by actually inserting some HTML into the notebook, which we can do very easily because notebooks work as a combination of Markdown and Python. And if you don't know Markdown, it really doesn't matter at all. But what we're going to do is start by importing a couple of things from IPython. And again, this has absolutely nothing to do with the rest of the course, but from IPython.display, we're going to import Markdown and display. Okay, so that's the first piece. And then what we can do is call this display function at any point, and then call Markdown. And inside, any HTML I provide inside of quotes, like an H1 element. If you're familiar with HTML, this makes me a heading. If I execute this, what did I do wrong? No module, it's IPython with a capital P. You can see that it renders me an H1 element. If I instead did a button, click me, it renders me an HTML button. Now it doesn't do anything, of course, but it is HTML. So we can use that to then render something for each one of these colors. And then what we'll do is inject the style into here. So this involves some CSS. If you're not at all familiar with CSS, it's okay. But I can do things like color is red. And I don't want to, this will work for a button. You can see it's a red text button. And I could do that for each one of these colors in a list. So we can start by defining a function we'll call it like display colors, and it will expect a list of colors. All right. And then inside, maybe I'll just start with one, display color. Inside, I'm going to call this display markdown. I'll keep it as a button for now, which I probably don't want to do. But then I'm going to make this an F string where this value will be our color that's passed in. And so now hopefully I should be able to call display color with orange. Oops. And that makes me an orange button. But I should also be able to pass through one of these hexadecimal color codes. And that's a pinkish color. But instead of a button, we have to decide what element do we actually want to display. And I think our best choice is going to be to use a special Unicode character, a block, and then fill that in with the color. We could do something more complicated like make a div or even do it with text. But with text, it's just kind of sparse. You barely see the color. I want to see a block of color. So what I can do is use a special Unicode character, which I already have open as I showed you. It is, the code that I'm going to use is 9608. So let me just show you what this looks like. Instead of doing a button, I'm going to have an F string. And then in my F string, I'm going to create a span. Span is just a generic element in HTML. And then inside, I can use some Python to help me here. I'll use the character or the CHR function, which converts an integer like 96, is that what it was? I already forgot. I think 9608 into the resulting character code. And there we are, we get a single block. And then I can give that the correct color. So I'll do style equals color, and then I'll interpolate the actual color that was passed in. And now I have a pink block. Or if we did it with this one, I have an orange block. All right. And the next step here is just to do this for an array of colors. So I'm going to call this colors. I'll change my function name to display colors. And then I'm going to, why don't I just take this whole list for now and pass it through, which it's not going to work at the moment because I'm only expecting a single color in here. So I'm going to loop over and do something for each one of these colors. And the easiest option here is to use a, inside of our markdown function call, it wants a single string. So what I'm going to do is call the join method on just a space character, which will return a big string. And I'm going to do this for each color in colors. And I'll just put them on separate lines to make it easier to read. Okay, here's a final version. So we're going to, starting from the inside, build an F string where we have the color set to the color coming in from this line right here. For each color in colors, return this string, and then we join them all together into a big string separated by spaces. Let's just see if it works. There we go. We're getting our color palette. That's good. And if you're confused on how this is working, we can just print out that string just to show you that. Do something like this. Print the string that we're creating using join, and there it is. It's just a big old string so that we can pass that one string in to display as markdown. So if you prefer to do that in separate steps, you can. If you're confused on using any of this syntax, it's sort of a Python-y way of doing it, just keeping it brief. But there we go. We have our color palette. And the only thing I would change here is maybe instead of doing one of these Unicode characters, I might actually multiply it by like 4 or 5. And there we are. We get wider swatches. Okay, so we're very close. The next step is to take the result. By the way, I just moved the function up here. It's more of a helper function, so it doesn't have to go up high. You just have to make sure to run this first before we then try and use the function. So not that important, but it makes it easier if I want to run everything all at once. So this function needs an array to be passed in. And what we have right now looks like an array or a list in Python. It's a JSON array, but it is not a Python list. It's a big string. And if I stop printing it, we can tell that. If we look closely, right, there's quotes around the whole thing. So it is not an array or a list in the world of Python. I need to parse it as JSON. So I'm going to import, just do it down there, import JSON. And the JSON module has a function or a method called loads. And I'm just going to provide this json.loads to that function. So this will take a string of JSON and convert it into Python, hopefully. And now this is actually Python. If I save that to a variable, I'll call it colors. I now should be able to do things like, I guess I'll do it down here, colors of 0, right? And we're getting that first element in the list, which now means I can pass it directly to display colors. It's expecting an array. Let's see if it works. All right, so that's my sunset color palette. Let's try something different, like ocean tones. Let's see how that looks. There we are. We're getting 4 colors this time. And that's pretty much it. We can tweak our prompt a bit more if we're not happy with how it's working, but it is working, right? It's giving us hexadecimal colors as a JSON array that we can then take and parse, right, and turn it into Python, loop over each color, and then render each color. The next big step is actually building a web app with a server and a front end, making it so that each color is displayed here in HTML. I can click to color the hexadecimal code, click to copy the hexadecimal code, search to make a new query, and just building a UI around it. And that's a bit more work, but the prompt itself is pretty much the same. It's not going to change at all. One thing I might change though is here, I'm going from Q&A, Q&A, Q&A. I'm going to want to keep this format just to be consistent. And I'll have A. And then right here is where we'll actually put the prompt itself. And the last thing I want to do is actually turn this into a repeatable function. So I'm going to put an F string around this whole thing, and I'm going to indent all of this into a function, which I'll call, what should I call it? Like get and render colors. And we'll take a prompt. But I'm already using the name prompt in here, so why don't I call this text message, something like that. And then whatever we pass in here, I will add in to the end of our prompt. I made it an F string so that I can then interpolate it right there. So message and message. And now I should be able to do, if I execute this, get and render colors, and then pass something in like for Google brand colors. And we get 4 colors that are from the Google brand palette. And let's try one more example. How about Thanksgiving color palette? So American holiday, Thanksgiving, autumn, lots of browns. Yeah, that looks pretty accurate. Good enough. So we have our color palette generating function, right? Using OpenAI, pass it a big, relatively long prompt. We get our colors back, and then we pass them into this function that displays them just in Markdown. Next up, we'll build a server. Welcome back, everyone. So in the next few videos, we're going to expand upon the color palette generating function that we have in a notebook and turn it into a standalone web app with a Flask web server and some JavaScript, HTML, and CSS to build this front end. And I want to reiterate that this is not essential to the course. It's just a fun project we're going to build out. But if you want to move on and learn more about the APIs, you can totally skip this section. With that said, we're going to be using Flask to build the web server. Now, if you're not familiar with Flask, it's very simple. It's a very lightweight server-side framework in Python, kind of like Express if you've used Express with Node. If not, it's not a big deal. And then we'll use HTML, CSS, and JavaScript to make the front end and do some of this logic where when I click, it actually copies the hex code and makes it somewhat useful, right? Where I could actually search for colors I wanted. Maybe I want the colors of the, what's a good flag? The Italian flag. And then I need to use them in my code. Well, I can copy them, paste them, and I have the colors. So we'll do some JavaScript to make that work. Anyway, the first step here is just to get our server up and running. So I'm going to be working from the terminal, and I'm in a brand new directory, completely empty directory. And in this directory, I'm going to start by making a new virtual environment. And then I'm going to source that virtual environment. And if all of this is brand new to you and you're feeling overwhelmed, first of all, I advise you just to sort of stumble through it and try copying me. But also you can check out some basic Python courses. I misspelled source, by the way. And I may or may not have some basic Python courses you can take a look at. Okay, so I'm now using this virtual environment, and there's a few dependencies that I'm going to install. The first thing I'm going to install for sure is Flask. So that's the web server tool that we're going to be using. Okay, so it's installed, and the next thing I'm going to do is make a new file. And this will be app.py. This will be my main Python file. It's really the only file I need, where I'll put the server logic to create the server, the different routes. And now I'm going to open up the whole folder in VS Code or whatever editor you like to use. I'm using Visual Studio Code, sorry. So I'm going to ignore the OpenAI stuff for a moment and just get the server up and running. I'm going to import from Flask, import Flask, and then we're going to want to use render template and request. I think I might be zoomed in a tiny bit too much. And then I'm going to go ahead and set up Flask. So the simplest Flask setup looks like this. Don't forget these double underscores there, the dunder name. And then whatever parameters I want to provide. And the first, really the only thing I'm going to do is say there's a template folder set to templates. And then I'm going to make that folder. So I'll make that now. Templates. Okay. And the way that Flask works is that we define these routes, different paths that we want to match. So let's just define our main route. It looks like this. We use a decorator syntax, app.route /, if that's what I'm trying to set up a route for. Then I'll write a function. We'll call it index. And I'm going to return render template. So this is a template that doesn't yet exist. And actually, even before that, I'll just return something simpler. A string. Hello there from Flask. And then at the very bottom, I'm going to add this little bit. If name equals, in quotes, main, app.run, debug equals true. So the next thing we'll do is go to my terminal and try starting our server. And we'll do this. Flask run. And it looks like I'm already using the port because I have my other server running. I could either specify a different port or just shut that server off. One moment. Okay, I turned off the other server. Then I start Flask run, and this begins my server. And it shows me the URL to visit. So I'm just going to copy that URL, open up my browser. And here is our very first Flask route. Just our index route. If we go to /nothing, we're returning hello there from Flask. Right? I could define another one. We don't need another one really, but I'll do one like /dog, and I'll call this dog. The function name doesn't really matter there. And then I'll return hello woof. Not hello. I'll return woof woof woof. Now my server is not going to live update for me unless I turn it off and I add in --debug. And this will now have it automatically restart whenever I make changes in my actual code files. So now I can go to /dog and I get woof woof woof. And if I go to just slash, I get hello there from Flask. All right. So that's our basic Flask setup. Nothing terribly exciting, but now we have a server up and running where I can define different routes. And the structure of our app is the next thing that we're going to cover in the next video. So I'll shut up for now, and I'll be back soon. Okay, so our next step here is to set up our basic routes. And the structure of our application is going to be very simple. We're going to have a single template that we render. It doesn't exist yet. And this template will have some HTML on it, some JavaScript, some CSS. And then when that loads in the browser, a user can search, right? Enter in their search. Do I have it open still? Yes, we can enter in our search term here, or our prompt, generate, and then that will send a request to our own server to a second route that doesn't yet exist. And this route will do the job of actually calling our OpenAI completion endpoint, make the request, get the palette colors back, and then respond with those palette colors back to the front end so that we can render them. So it's going to be a single page app, meaning we're not going to have any page refreshes, right? We have a single template, and then it is requesting via Ajax, it's going to request our server. So if all of those are foreign terms to you, it's okay. There's a lot there, and I'm obviously not going into detail on any of it. But if you're along for the ride, just sort of give up having to understand every piece and just follow along, and you should be fine. And then if you want to learn more about Ajax or routing or Flask, you can definitely pursue that, but don't let that get in the way of completing the project. All right. So I think we'll start by setting up our template, just a dummy template to return. So app.route/, that's our home page. Instead of returning hello there from Flask, I'm going to return that render template function that I imported up top from Flask. And I'm going to render index.html, which doesn't yet exist. Now I told Flask all my templates are in a folder called templates, and I made that. Now I need to make a file called index.html. And then in here, I'm going to type !tab. I'll call this title color palette generator or something. And then I'll put an H1 that just says hello. And hopefully we see this template. So let's see. Do we see it? If I go to /, yes, we do. We're getting our index.html. And we could spice it up a bit. Just quickly, we'll delete this. But if I added a style tag at the top in the head, I could select H1s and give them a color of purple. Refresh the page, and we see purple. So this just tells us, okay, we're getting a full HTML file now. We have a template, and then we can build that template out. The next piece is to actually work on the most important route, which is the route that we will send a request to from our form that will then make a request to the completion endpoint and hopefully get us some colors. So this route will not return a template, and I'm going to set up the route to be palette, and I'm going to make it a post route. So methods equals post. So you'll have to send a post request to hit this route. And then I'm going to call this something like get palette, or what do we want to call it? Prompt to palette or something like that. And then in here is where I'll actually make my OpenAI completion call. And then at the end, return list of colors. So in order to make an OpenAI call, of course, I need to import OpenAI, but I also have a virtual environment set up, and that means basically I'm going to install OpenAI here. So pip install OpenAI. And I'm also going to do a pip install .env, because remember, we need the environment variables, and it's actually python.env. I don't know why. When we import it, it's just .env, but the name of the actual package is python.env. Okay, so now I'm going to import OpenAI. And just like before in a notebook, I'm going to have to provide my API key. So I'll import it, and then the way that I'm going to go about providing my API key is using a .env file. So I'm going to make a new file in the top directory of my project called .env, and I'll follow the same format that I did for my previous .env file. So I'm going to say OpenAI API key equals, and then actually put my API key right here. That's not it. I'll put it in there and then save the file. Okay, so I have that API key in that file. The next step is to import or get access to that API key and provide it to OpenAI. And I'm just going to reuse what we did earlier in a notebook. So I'm going to import .env_values from .env. Okay, there we are. And then I'm going to call .env values. And that will return to me something I can store in a variable. And I'm going to call it with .env as the name of the file. So look for that file, and whatever you get back, put it in this variable called config, and then hopefully I'm able to access config OpenAI API key and set that as the OpenAI dot, and I can't remember what they're looking for. Yeah, OpenAI dot API key. So hopefully this is all recap. Load the values from my file called .env, specifically take the OpenAI API key out and set it as the API key property for the OpenAI package that we imported. Okay, so the next step is to test if our OpenAI API key is set up correctly. And I'm going to do this in our index route for now. So if we go to if we make a request to /nothing, we're going to return this template. But before we do that, I'm going to do an OpenAI.completion.create. We'll do just a very simple completion. So model equals text DaVinci 003. And our prompt will be very simple, like give me a funny word. It doesn't matter. We're just testing to see if this works. We'll save that to a variable. And then what we want to do is, what is it again? Response, is it called choices? I can never remember what we get back. Yes, choices, 0, text. So this will give us whatever we get back, hopefully. And then the final thing that I'm going to do is print it out, or maybe we'll just return that instead of our template and see if that works. So if I go start my server up, oh, what's it mad about? Expected an indented block. Oh, this is the problem. I have a function here with no body. Okay, try that again. Now if I go to /, there we go. I get Goofwinkle. If I do it again, I get Snozwanger. All right. So that tells us that OpenAI is set up correctly, right? It has the API key. We're not getting an error. Now, this is not where I want to make a request. That will be in the next video. We'll actually set up our endpoint and test that out. Okay. All right. So we have our basic Flask app set up. We've got our index route. What I want to do now is start to work on the actual route that the front end will call. Right, when I submit this form, it sends a request via JavaScript to some endpoint. I'm calling it /palette, even though it's commented out. And then that should take the text from the form, pass it over to our API or to the API to get the colors back from GPT, right, from the completion API, and then return and respond with that list of colors so that front end stuff, JavaScript, can then do something with the colors and add them to the page. So in this video, I want to get this route working so that when I submit data to it, it will generate the colors and respond with them. So I'm going to turn this back on. I had it commented out. Leave these as comments. It's a post route to /palette. So when a post request is sent to our server to the URL /palette, this code in here will run. And the simplest thing we could start with is just printing out something so we know that we're hitting this route. Because when it's a post route, I can't just visit it in the browser, in the URL bar. I need to send a post request somehow, usually from a form or from Ajax, from some sort of library sending a request. Or what I'm going to do to test it in this video is use a tool called Postman, which you don't have to have, by the way. So I can't, unfortunately, just print something. My prints are going to be ignored by Flask. What I can do is reference the app right here that I set up. It's the result of executing Flask. And I can use the app.logger. Is it logging? Logger? I always forget. We'll find out in a moment, won't we? App.logger and then something like .info. There's .warning, I think. There's .error. And I'll just say, hit the post request route. Okay. Not getting any errors here yet. That's good news. So now let's try sending a post request to this route. Okay, so I'm using this tool called Postman that's going to help me make a request. It's just an easy way to test our APIs. So I'm going to send a request to /palette. Here's my local server URL on port 5000 /palette, and it's supposed to be a post request. And I'm going to send that. We're not really responding with anything at the moment, but let's see if it did indeed print out. Did it print out? It looks like it's there it is. Yes. Hit the post request route. Okay. So it is hitting that route correctly. But now what I want to do is actually generate colors instead of just printing you hit the post request route. So the first thing I need to do is extract the form data that is sent, which eventually will be coming from a form. And the way that we do that in Flask is we have access, as long as we import request, we have access to, I'll print it out, request.form. And then I can ask for a particular piece of information, whatever I expect the data to be named. So I'm going to expect it to be called query. And now when I send a request from Postman, I can do the same thing, but I can actually specify in the request body that there's a piece of information called query, and its value is midnight on the highway colors. Now we're not doing anything with this information yet, but if I send it and I go back to my terminal, we hopefully see, we hit the post request route, and then we also see midnight on the highway colors. So that worked. Eventually this will actually come from a form or from a request being sent from JavaScript. At the moment though, it's just coming from me testing it with this app called Postman. All right. So the next step is to take whatever this value is here. Let's call it query. And then I'm going to generate the color palette using whatever this is. So at this point, I'm going to copy over, let's see if I can find my original function that we wrote a couple videos ago. This is the one that actually does the prompt and sends it over as a completion with Text DaVinci 003. And then we'll have to tweak it a bit because it's also rendering our colors using Markdown. I don't care about that. But I'm going to copy this and I'll put this not in a route, just on its own. And I'm going to rename this to just be get colors. So get colors expects us to pass in a message. And that message will be appended using an F string to our prompt, right? So we tell it, here's an example, here's the colors. Here's an example, here's the colors. Here's what I'd like you to generate colors for, and then you give me the colors. And so we'll put that message in there, whatever it is, Lakers NBA colors or something. And then we're almost there. I'm going to send that request. We hopefully get a response back. The only thing that we need to change for now is that we don't want to call display colors. That doesn't exist. That was our function all the way over here that renders Markdown to make these little swatches. But we're not doing that. I just want the colors to be returned as a Python list from this function. So I could start by just returning colors. And then in this function, in my route handler for /palette as a post request, I have my query. I'm then going to call get colors and pass through the query. So this is whatever is coming from the form, whatever's in the body of the request being sent to this URL as a post request. Whatever that is, Google brand colors or chilled out pastel colors, we're extracting that from the request. passing it to get colors, which actually does the completion request. And then hopefully that returns the colors, and we'll print them out. So we'll call this colors that we get back, and we'll print out colors. And actually we can do just a return colors too. And we hopefully will see that returned when I use Postman. So let's see. I'm going to do midnight on the highway colors to that endpoint. And oh, we get an error. It's saying name JSON is not defined. I think our function uses JSON. JSON.loads. Yeah, right here. This is what actually takes the string version of our colors in what looks like an array or a list, and it turns it into a Python list. But I have to import JSON. Okay, so we hold our breath again, and we try again. Same request. All right, and we get a list of colors here. So we don't know what they look like yet, but we do get a list of colors, right? 5 different colors as a list. Technically, if we're going to respond with JSON, what we need to do is put everything in a JavaScript object. So here where I'm returning colors, that's a list. It will look like, what we just saw, a list of colors. Instead, we should really return a Python dictionary, which will be turned into a JSON object, curly braces, and we'll set colors to be equal to colors. Now that won't make a big difference. It's just more valid in terms of writing JSON. Everything's supposed to be stored in an object under some sort of key. So I can get rid of the loggers for now. Get rid of my comments. And hopefully if I do this again, I'll just do the same prompt, midnight on the highway colors. Now we get a JavaScript object that has colors, and it's set to a list of colors. Okay, so we have our endpoint set up. In the next video, we're going to start working on a form that will actually send data to that endpoint and get colors back and then render them for us and make what you see here. So we'll do the front end next. Welcome back. Now that we have our endpoint set up, basically our internal API, right, that exposes our colors as JSON, it expects you to pass in something for a query property in the request body, probably coming from a form, and then it will take that query, pass it to our getColors function that sends our completion request to OpenAI. We get a response, we parse it, we return that, and then we return some JSON here. Okay, now what I want to do is connect a real form on the front end so that it's sending that data and getting it back and getting the colors back and then eventually rendering them. So instead of, first of all, we can get rid of all of this. It's just generating a funny word. And I'm going to go back to simply rendering our template called index.html. That's all this route needs to do. Here's our index. We see hello in purple. That's fine for now. Eventually, I'm going to move my CSS into a file. I'll move our JavaScript into a file. But for now, I'm going to put my script directly in line. So I'm making a script tag. By the way, this autocomplete, I just type the name of a tag and hit tab. And in here, I'll do something silly like hello. Let's make sure that that pops up. And we do see hello alerted. Okay, I'm going to get rid of that because it's super obnoxious. Now I'm going to add a simple form. And I'm not going to put an action or a method on this form because I'm going to simply use this form to show a user a form control to show them an input. I'll give it a name of query. And then I'll give it, for now, that should be fine. I'll give this button some text to say submit. And we'll just start with this. And normally what would happen is when we have a form, you put something in there. If you hit submit, it sends a request. And that still will happen. It refreshes the page. I don't want it to do that. Instead, what I want to do is extract the information from the form and then use JavaScript to send my request. So there's no page refreshes, and so it acts as a single page app where it happens seamlessly behind the scenes without refreshing the user's page. So our form is just there to be, visual, to show a user an input and a button. Technically we don't even have to have the form, but it's a good practice to wrap them. And that way I can listen for a form submission and then prevent that behavior. So I will give my form an ID. Why don't we call it just form? And then I'm going to select that element using JavaScript. So I'm going to make a variable. And if this is all new to you, if you're a Python person, this might seem a little crazy. But what I'm doing here is calling a special method called document.querySelector. I pass in a special syntax. This # means I'm trying to find whatever element has the ID of form, which is this whole form here. And then whatever elements returned by that, should be our form, hopefully, we'll store in a variable called form. And then I can add an event listener. And I'm going to listen for a submit event. And then I'm going to put a function in here that runs when our form is submitted. And the first thing I'm going to do, we have access to an event parameter, I'll call it E, is called e.preventDefault. That just tells the form not to submit a real request. Stop your normal behavior, and that will stop the page from refreshing. As you can see here, when I submit this, our page is no longer refreshing. And then I can do something like console.log submitted event. And if I open up my console, every time I click, we are seeing, it's hard to see the font there, but submitted event being printed out. All right, so we have our form. Now what I need to do is, instead of just printing out submitted event, I need to extract the information from this form, right, from this input, whatever that text is in there, and then I need to forward that, I need to send a request, so my data is sent to our API to /palette, right here, as a post request. So the first thing to do is to get the data out of the form. And there's a lot of ways of doing this. What I'm going to do here is select, I already have my form variable. I'm going to do form.elements.query.value. So form.elements will hold references to any of the elements in the form. This one, whoops, it's right here, specifically has the name of query, which is what I want, and I want to extract the value. So let's console.log that, and hopefully that has whatever our value is typed into this field. And there it is. So if I do something like NFL, I don't know, Steelers colors, I hit enter instead of clicking, that still submits the form, and we see that printed out here. So the next step is to generate a request. And there's a lot of ways of sending requests from JavaScript, including some libraries like Axios that make it way easier. What I'm going to do is use the fetch API in JavaScript. So it looks like this, fetch, and then where I'm sending a request to, which is /palette. And then I have an object that has different parameters, and one of which is I want to send a post request. And then I'm going to send some body information. And in this body information, I'm going to set the query parameter to be our query right here. So I need to save that to a variable. I'll just call it query. Okay. So under the name of query, send the data in the variable query, which is what we got from the form. We'll see if this works. There's always a little tweaking that has to happen. So this will send a request, and then we can run some code when it's done using the .then method. This will return a promise. If you're new to JavaScript, this is absolutely overwhelming. Don't worry about it. And this will give us a response. So let's call this parameter response. I'll do an arrow function and parse that as JSON. This is how we parse it as JSON in JavaScript. And then I'll do another .then because response.json actually is, it can take time. It returns a promise. So when that finishes, we'll have some data, hopefully. And let's console.log data. We'll see if this works. It will work eventually, but it's easy to make a mistake the first time through. Okay, so I'm going to search for NFL Steelers colors. I'll open up my console. I'll submit this. And we get back an array called colors, but it doesn't have any information in it. Ah, I know what's wrong. If we look at how our app.py is set up, app.python, it's expecting our data to be sent in a form encoding. So we can also set up this route to expect JSON. So we have a choice. Do we send JSON and anticipate JSON, or do we send form data and anticipate form encoded data? I'll just change my request here. It's kind of a pain. I'll show you what it looks like. So just to tell the request, as part of the request, to specify that we're sending form encoded data, it looks like this. Headers, and then we have to specify the content type header. And then we set it to application / x www - form URL encoded. So this now says in the request, we're providing you with some form encoded data. That's not quite enough. I then also have to change the body here and wrap it in URL search params and put those parentheses around this. So this will encode things properly to be a JavaScript, take a JavaScript object format and turn it into URL search params. Let's hold our breath. Let's see if it works this time. So I'm going to search for, I don't know, neon colors, submit, and there we are. We got a color array with 4 elements. Whew, okay. So our request side of things is pretty much done. When you submit this button, we'll move this to a separate file, we'll clean up the JavaScript, but when you submit the form, we prevent the default, we extract the query value from the input that has a name of query right here. Then we take that, we send a post request to /palette, and then we say in this request, by the way, this is being sent as form data. Here is the form data. We put the query in there, we get a response, we parse it as JSON. When that finishes, right, these .thens, they run in order. This will happen. When that finishes, we parse the JSON. When that finishes, we print out the data. That's all we're doing for now. Next, we'll actually render the colors. Okay, moving on along. We now have the form working. I can send my data and get the corresponding color palette data back. The next step is to render the colors. If this is what we're getting back, I want to go into the colors property of this data. And then for each one of these colors, what I'm going to do is make a big block of that color on the page. So the first step here is just to get the actual colors out. So we have data. The part that I care the most about is called colors. So I'm going to extract the colors from data.colors. And then with those colors, what I'm going to do is loop over each one of them and create a div, some HTML element that I'm going to append to the page. And the first thing I'm going to do is make a place to append those elements. So I'm going to make an element here. I'm going to call it container. And our container is just going to be an empty div. And I'll write some styles for the container to give it a black background color so we can see it. And I'll also make it full width, 100%, and height is going to be 100 VH, which is viewport height. So we should see, when I refresh, a very big black box, and we'll worry about moving that around and styling things later. Then what I'm going to do is to this container, I will append other divs based upon the different colors that I get back. So I have this div called container right there. And again, this is getting kind of sloppy, but I'm just going to refactor this at the end. So I'm going to select my container. I guess I'll do it down here. This is when we have our colors back from the API. So the way I select it, I'll use query selector. This one has a class name of container, so we use a dot. Document.querySelector container. And then I'm going to loop through for each color of my colors array. What I'm going to do is make a new div. So const div equals, and the way that we create a div is document.createElement. And then I specify the tag name, in this case a div. So that makes me an empty div. Then what I'm going to do is give this div the right background color. Div dot, and then I can do style dot background color equals whatever the color is that I'm looping over right here. All right. So the next step is to take each div and append it to the container. Container dot, and then I can call append child with each div. So if I get 4 colors back, we're making one div appending it to the container. Second div append to the container. We do that 4 times. Now our divs don't have any height at the moment, and that's going to cause us problems. So if I try this right now and I submit, pastels, I'm not going to see any divs, anything visual here. If I go to the Elements tab, though, we do in fact have 1, 2, 3, 4, 5 different divs showing up. And that's what we want. I got 5 colors back. We made 5 of them. The problem I have is that they have no height and they have no width. So the first thing that we'll do is give them a width. And this is going to involve a little bit of fancy math. I'm just going to divide up. If we go to this example, 3 colors, each one should get 33.33%. If I have 4 colors, each one should get 25%. So I'm going to divide, let's set their width, div.style.width equals, and then the simplest way of doing this is actually using the calc function in CSS, calc 100% divided by, and then I'll interpolate inside of here. Let me close my string template literal, the length of the colors array. So this will be replaced with 5. And this will then take 100% and divide it by 5. So I don't have to worry about appending the percentage sign and doing the math first. Instead, I'll let the calc function in CSS take care of that. So that should give each one of them a width. The final step is setting them to have a height. And what I'm going to do is select a class that doesn't exist yet. I'm going to call it color and give them a height of 100% of their parent. And then I'll append that class to each one of these divs that we're creating. So div starts as an empty div, but then I'm going to select the class list, and then I'm going to add the class called color. And that should then set each div to have a height of 100%. The width is dynamic and the background color is dynamic. Let's see if it works. So pastels. Okay, well, kind of. Yes, there they all are. It's working. Now the styling is horrible, but we are getting the colors. So next we have to worry about CSS and actually getting our colors to display in a row instead of displaying in a bunch of individual rows. But we're getting pastel colors. Let's try one more. I keep going back to the Google brand colors because those are just easily identifiable. I don't know if I hit submit. Oh, it did work. However, we're just continuously appending over and over and over. So we have a lot of changes we need to make, but we are getting color showing up. So I'm going to stop here. In the next video, we're going to fix a lot of these problems. Okay, so next we have some important changes to make. First of all, every time I search, it's just appending new boxes to the page, which I don't want. So that's an easy fix. When the form is submitted, we get our colors back. Before we append new colors, what I can do is empty out the container. So container.innerHTML equals empty quotes. And now if I search for colors, I don't know, pastels again, it should, they're still not going to be in our box visually. They're just going down the page. We'll fix that in a moment. But then if I do something else like Airbnb colors, these should be replaced as you see right there. Okay, the next change is a stylistic change. The way that these boxes are displaying is in a row. And if you don't know anything about CSS, these divs are what are called block level elements or block elements. They don't share the space. And the easiest way to make them share the space is to select my container and give it a display of flex. This enables something called Flexbox. Now if I try another search like pastels again, hey, take a look at that. It's a lot closer to what we're trying to get. We're getting our color boxes in a row now. So if I do something else, how about sunset on the beach? Here's our sunset colors. Okay, and they're replacing the old ones that were there. So let's get rid of this H1 that no longer has a purpose. Not that it really had much of a purpose ever, but we really don't need that. And we'll worry about styling this to be full width and moving our form into the middle in a little bit. This is still valid, or still good enough. Next, we have some functionality I'd like to add in. So when we click, we can copy and paste a color code, and the color code will actually show up when I hover. Right now, we don't have any of that. But it won't be too much work, I promise. The first thing is when we append our colors, let's go back to sunset colors. All that I'll do is append, I like these colors, it's nice looking, by the way. I'll append a piece of text, probably a span, into each one of these divs. So it's super easy to do. Here's where I'm making my div. I can just make a new element, I'll call it span. Document dot create element. I want it to be a span. And then I can set that text in the span to be anything that I want. So I can do span dot inner text equals, and then I'll just do like hello. And then I append that span, if I spell it correctly, to my div. Div.append child span. And then finally, we append the div to the container. So we make an empty div, give it the color, we make a span, we append that span to the div, so it's nested in the div, we append that div to the container. Let's try sunset again. Okay, now where are the spans? They're up top. We can worry about moving them around in a bit, but let's make sure that they actually show the color code. And we have that. It's just called color. It's what we're looping over. So for each color, we're working with a variable called color. It's a hexadecimal. So I'll just say your inner text is color. Try it again. Sunset. And now we have the hex codes showing up. Again, I'm not going to worry about styling. I'll put that in a separate video. The next piece then is how do I copy that color when I click on this div? And the way that we do this, it's not too bad. There's a special object called navigator that has a clipboard property that has a write text method. So what I want to do is when you click on one of these divs, and we'll refactor this in a bit, but here's our div. It has the right width, the right color, the right class. I'm going to add an event listener for when you click on the div. And when that happens, what I'm going to do is select our navigator.clipboard.writeText method, and I'm going to write the text of color. So whatever I pass in here will be written to your clipboard. So if you click on a div, we'll pass that color through. And let's verify that it works. So sunset again. Okay, let's take this one right here, BD3E. I'm just going to click on the div. Now you can't really tell that anything happened. We'll add some CSS to make that clear. But let's look at my clipboard. If I paste this in, I copied it. If I click this one, I paste it in, I copied it. Nice and easy. Okay, so that's actually all there is for the logic. I guess one thing we should do is clear. Possibly, we can decide if we want to clear the input or not. So when I do a search for, pastels for colors, that stays in there. And actually, I think it might be nice to keep it in there because then you can see what you just searched for. A common approach would be to then empty out the input, but if we did that, I might want to display the name of the prompt or the query up top so you could see it. But anyway, this works. So all we really have left is some annoying styling. So if you care about that, we'll get to styling it so our input looks better. It'll be centered in the page. When you hover, we'll see the hex code, and when you click, we get a little animation just to show that you're actually copying something. Because right now you can't tell that anything happens when you click. So that's all coming up. If you don't care about styling, we're pretty much done. And we'll refactor this long JavaScript, move it to a separate file. All right, so it's time to do some styling changes. Again, none of this has anything to do with OpenAI or any of the APIs. It's just about making this look better. So there's a couple small changes we can make. Right now, the form is not centered in the middle of this black box, which we'll address. But we have this extra spacing on the left and the right, and I want my color to be full width. So this is simple enough. I can just select the HTML root element and the body, separate them with a comma, and set their margin to be 0. If I refresh, now we have full width. Okay. The next thing that we'll tackle is once I put in a search in here like pastels, we get our pastel color showing up, great, but the text of the actual color is all the way at the top, that hex code. So I think I want it to go down to the bottom, and I also want it to probably be bigger and centered. So I'm going to use some Flexbox to help me with this. And if you don't know Flexbox, just buckle up. It's okay. I have, a CSS course, and we spend a couple hours just going over Flexbox. So it's not something that you could really pick up all that quickly. With that said, what I'm going to do is make each color. Remember, this class of color corresponds to one of these boxes here. I'm going to take each one and set its display to flex. And then I'm going to set justify content to center, and this will center everything horizontally. So if I do another search, pastels again, you can see our content is now centered. And then to push it down to the bottom, there's a lot of options. I'm going to use align items flex-end in my CSS. It's kind of annoying. I have to search every time. I'll do pastels again. Okay, so now our text is down there. Although I think it's too far down, right? I want a little space. So what I'm going to do is select the spans inside of each color, which is the hex code that we see right here. And I'm going to make them probably a little bigger. Let's see what 3 rems looks like. And then I'll give them a margin on the bottom of 2 rems. How's that look? Let's do a search for sunset. Okay, so 3 rems is too big. So let's downsize maybe to 2 rems and see how that looks. Do another search for sunset. I didn't refresh the page. Sunset. And that can work, although depending on the size of the screen, that could still be a little tight. I think that's fine for now. You can adjust that and decide what looks good on your devices. If I shrink this down to a small screen, it really does not look good. But we're not worried about making this responsive. Because ideally, these would probably start to go into a column-based layout, a single column with multiple rows instead of what we have here. Anyway, it's still a little cramped, so I'll just adjust this maybe to be 1.5 rems or something. But the space on the bottom looks good to me. Then we have to worry about the color. They're black by default. That's not going to look great on a dark colored image or a dark colored background. But also if I go full white, it's not going to look great on a white color. So I have some choices. The fancy way of doing this would be to do some math with the colors and figure out how dark this background is, and then change the text color to be white or black depending on how dark the color is. But we're not going to worry about that. Another thing we can do though is add a text shadow. So I could make them have a color of white and then give them basically a black text border. Text shadow, and I can do like 1 pixel offset black. It doesn't look great, but it will show up better on more colors, right? So you can see the white there, but there's a black background around it. And so if I have a very light color, like boring colors usually gives me grayscale, you can read it relatively well, right, on this gray, but also on this pretty light colored, almost white. It's easier to read just on a bunch of different colors. Okay, the next thing I want to do is very simple. I'm going to set the cursor on each color to be pointer. And this means when I hover over a color, if I do another sunset search, I can't zoom in to show you, but you can see the cursor sort of looks like I can interact now. And I can interact because when I click, it copies the hex code. Don't forget about that. Let's copy this one, C9A, and it's on my clipboard. what I want to do is have a little visual indicator of the fact that you clicked. Now these aren't buttons, but what we can do is style each color in its active state. So what I'll do is select the all colors in their active state when they're being clicked on. And I can change really anything, but what I did in my example was change the opacity, which goes from 0 to 1. 1 is full opacity, 0 is full transparency. So 1 is fully opaque. I can dim it a bit, like 0.8, and let's see how that looks. So I'll search for sunset again. So as I click, you can see we get a little change there. It's not spectacular, but it at least indicates that something's happening. And then I can also go to my color and add a little transition, a very short one, 0.2 seconds for opacity, and this will animate it just a tiny bit. Let's do more sunset colors. So now it sort of fades in and out. Slightly gentler, less abrupt. Okay, so the final piece here really is, I can change the fonts, but is putting this form in the middle of the page, which you can see here. I want it to be centered in the middle of the page. I'm way zoomed in on this, but I want it in the middle, and I want it floating on top of everything else, and then we'll change the color of like the button and the text input if we want to. That is our next goal, and for the sake of time, I'll split that into its own video. We're almost there. Welcome back. The next step is to style the form. So I want it to look different. Green button that's sort of flat. Our input is also flat, has a grayish color. But I also want it to be in the center of the page, floating on top of our colors. Or when the page loads, floating on top of this black background. So to do that, I'm going to use positioning. So I've wrapped everything in a form with the ID of form. I can select that element with the ID of form. And what I do, if you don't know about positioning, again, another topic that it's not terribly difficult, but it may not make a lot of sense up front. I'll set the position to absolute. And what this will do is take the form out of the regular flow of the document and allow me to position it using things like top and left. If I set the top offset to 0 and the left offset to 0, our form now goes to the top left corner, which is better, I guess. It's stacking, but that's not where I want. So I can push it down by increasing the top. Let's try like 300 pixels. And that pushes it down. I can push it over if I set, 600 pixels for the left. But then the trouble is, well, how do I get it exactly in the middle? And there's a lot of options, but the easiest one is to set the top offset to 50% and the left offset to 50%. This won't work perfectly though, because it's offsetting this element by 50% of the height of the whole page and 50% of the width of the whole page. The problem is the element itself, the form, has a width and a height. So there's a little trick people use using transform, translate, which allows us to move something over. I'll do -50%, -50%. And you might be thinking, well, how does that work? If I'm pushing it down 50% and pushing it over 50%, but then I'm adjusting it -50 and -50, does that, just cancel each other out? The difference is, and it's kind of confusing, the 50% here refers to the width of the height of the overall page. The 50% here refers to the actual width or height of the form element. So we push it down 50% of the height of the page, and then we move this guy up 50% of the height of the form itself. So now it's centered. Okay. And it should float on top of everything. So if I do another sunset or Google colors or something like that, it still floats on top. Okay. So next we'll actually style the form itself. So in the form, we have, I'm just going to use my form selector here for the ID to select. There's only one form, but there could be multiple. Select the input, and it's a text input, right? So input type equals text, and I'm going to style this text input right there. So there's a couple things I'm going to change. I'm going to make the font size bigger. Let's try 1 rem to start. Let's try removing the default outline that it gets, and let's give it a background color of F2, F2, F2. This is just a light gray color. And when I refresh, okay. So it's not all that noticeable, but if I change this to be 2 rems, we can tell it's definitely working, and we might still increase that size. The next thing I'm going to do is add a border, and it will have a 2 pixel solid. Let's try a white border. Okay, that looks decent enough. Then we have the button itself, and we'll start by selecting that button. Maybe I'll just give it a class of BTN or something like that. I'll select all instances of that class and give them a green background color. Now I just picked this green color. It's 4CAF50. That's what it looks like. I'm going to give it a lot of padding, so increase space on the inside of that button on all 4 sides. Alrighty. I'm also going to add some padding to my text input. Same deal. 20 pixels or so. And then I'm going to increase the font size of the form or of the button. So let's go to 2 rems as well. Okay. The next thing I'm going to do is on the button, set the color to white. And then I'm going to get rid of the default border and give it a white border. 2 pixels solid white, just like we did for the text field. Okay, that looks decent enough. I'll also, what else should we do? I think I'm going to give it a little hover effect. If you can see that here, when I hover, the opacity changes. So simple enough. Select the .btn. When you hover over it, opacity maybe goes to 0.6 or 8 or something like that. And that's happening really quick. So I'm going to add a transition to the button. 0.2 seconds opacity. Yeah, that looks better. Let's see what it looks like on top of colors. Let me zoom out a bit. So here's 100%. It looks okay. I mean, I think it looks decent enough. We might want to make this actually wider for, there could be prompts that are significantly wider than sunset. So I can give the text input an actual width. I don't know what number will make sense. Maybe 400 pixels to start. Yeah, that's a bit wider. You could obviously make it even bigger. Another thing I'm noticing though, if I go to like Google brand colors, I was way zoomed in when I set the font size down here for those elements, the spans. So I think we probably can go to like 3 rems or 4 rems, which is what I tried originally. I just didn't realize I was so zoomed in. Yeah, I think that's fine enough. And that's pretty much it at this point for the styles. I'm sure there are many other tweaks we could make. It's not at all responsive. This doesn't look great down here still. That text isn't beautiful, but it's good enough, right? This is just a quick little project. The last thing we probably should do is refactor our code a little bit. Okay, so let's refactor our code. This is not looking great. The first thing we'll do is just move all the CSS out into its own file. So I'm going to cut that CSS out. And then normally I would have some sort of directory where I'd put all my assets or all my static files, which is often called static. So I could just make a static directory and make an app.css and put that right in there. Okay, so I have my app.css file. Then what do I link to when I'm trying to find that file? How do I find it? So I use a link tag just in CSS and HTML in general, but how do I actually find that file? So it's called app.css, but if I just put app.css in there and I refresh the page, it's not going to find that file. It doesn't know that it's in the static folder. So if I go back to my app.py, when I set up my app where I'm instantiating Flask, there are two parameters I pass in. Static URL path is an empty string, and the folder to find my static assets in is static. So that just needs to match whatever this folder name is. And then this here says I don't want to have any fancy path to reference over here. So I'm not doing something like, assets slash. It's just serving them as at the root path. So just app.css. If I refresh, there we go. My styles are back. And then I'm going to do the same thing for my JavaScript. So I'm going to make in the static directory a new file called app.js. And I'm going to copy all this scripty stuff out of here. Keep it moving. All right. I'm going to cut it out and put it in this app.js file. And then here, I'll keep my script tag, but I'm going to keep it empty inside and link to or set the source to be app.js, which it should be able to find. I'll refresh the page and let's see if the search still works. What's a good search we haven't done? How about coral reef? Yep, it still works. I like those colors. So we just move that code out. Just make sure if it's not working for you that you add these two lines, and then you have a static directory that matches the name here. So now let's talk about refactoring our code a little bit. The Flask file itself, app.py, it looks fine enough. It's pretty straightforward, very simple. Our CSS, we could definitely clean things up or at least reorganize. It's not bad though, it's so short. I think it's okay. But the app.js file is a little clunky, the way that it's structured now. At the very least, what I think we should do is move some of this event handling logic into separate functions. So this is pretty clunky right here. Once we get the data back, I think we should probably make a function called like create color blocks or something. Create color boxes. And it should expect a list of colors. And then it should expect the container or parent to attach them to. And then here we would move all of this code, or almost all of this code, right here, and put this in here, although we're going to have to make things work because colors here still is correct, right? If you pass through colors, we'll just call it color still. But I called this parent, so anytime I'm referencing container, I really should change that to be parent. Or I could have just changed this to be container. And then we will need to pass in, when we call create color boxes here, the list of colors, and then the container element. Let's make sure this part still works. Let's search for, how about autumn leaves? Okay, still works. We're getting our color boxes. The next thing that I would do is probably just, at the very least, make a event handler function I can pass in, so it's not nested. We also don't need this console.log here. I might make a function called like get colors. Function get colors. So I'll move all of this stuff. I'll keep the event.prevent default, but I'll put this all in get colors. And then in here, we'll call get colors just to clean up our code so we don't have any of these super long functions. There's many other ways we could clean this up. This is just a simple one. We're still doing this global selection of the form. It's fine. We could actually do something that's slightly fancier using the event.target to figure out which element this was called on, but it's not a big deal. Let's make sure this still works. Let's look for ocean in the morning. There we are. We get our colors. Our CSS still works. Let's see. Can I copy the hex code? This is 33A. Just make sure it works. Perfect. So that's pretty much it for the project. I mean, when I said refactor, we didn't do much. We just sort of moved some stuff out into separate functions. Still a very simple front end and a very, very simple back end. It's mostly just about that prompt. But it's still, honestly, it could be kind of a useful project if you're just trying to come up with some good colors. You want some combinations, some ideas, or you want to just steal colors like I showed from, 49ers NFL colors. If I want the 49ers colors, I've got them. Or if I want I'm a big Arsenal fan, Arsenal FC colors. There we go. I've got the Arsenal red. I mean, I assume that's close at least. And then white, simple enough, and then black. But, I quickly can get colors. Now, the accuracy is not guaranteed if you're looking for a specific shade of pink that Airbnb uses or the exact shade of purple that FedEx uses. But it's still kind of a fun visual search engine for color palettes. So I hope you enjoyed it. Next, we have a lot more to learn about the different APIs and actually more about the completion API before we wrap up with it. We have some important parameters left to cover. Next up, we have a couple of important, more technical parameters to cover when we're working with the completion API. And the first of these parameters is called temperature. So temperature is a value from 0 to 2, although usually it's just between 0 and 1, and we'll talk about why in a bit. Its default value is set to 1. And the point of temperature is that by increasing it, we can increase the randomness, what the doc sometimes calls the creativity of the output. So a lower value like 0 is more deterministic, meaning you're more likely to get the same answer over and over and over for the same input. And a higher value, like 1, or even something between 1 and 2, which is probably higher than you want to go, increases that randomness. And the way that it works, it really doesn't matter if you understand the details of this or not, because you can use it in the same way. You don't have to understand how to build, a crazy transformer model from scratch. We can just use the API. You don't really have to understand the math behind temperature in order to use it, as long as you know it's a number between 0 and 2. And lower number means less random, higher number means more random. But the way that it works is that it scales what are called the logits. And logits are basically a measurement of the probability over the next few possible words. And what happens is when we increase that temperature, the logits are then divided. So logits are this measurement of probability. They're divided by the temperature value before what's called the softmax function is applied. Basically what this means is when we have a higher temperature, we have a softer probability distribution, so a more diffuse distribution, versus with a lower temperature, we have a more peaked distribution. So here's an illustration of that. Where we have a low temperature, the distribution of probabilities for each upcoming token or word is more peaked, right? You can see this distribution. There's a more obvious choice or choices compared to with a higher temperature. The curve of probabilities here is a lot softer. It's more diffuse and spread out. And this means we kind of get more random outputs, less predictability compared to when we work with a low temperature. So if I lost you with logits and softmax, I mean, I didn't really go into much detail anyway, but if you're confused by that, don't worry. Just remember this diagram. Lower temperature, we have probably tokens and words that will have a much higher probability and a much steeper curve where there's an obvious next choice. Compared to a higher temperature, it's not as obvious, it's not clear cut, which is the best choice, the most probable choice, so we get more random or creative output. So let me demonstrate this. I have a new notebook, just make some cells in here, and let's do a simple completion. So openai.completion.create, and we'll use the text DaVinci 003, and our prompt will be something like, tell me a story. Let's just try that. And let's give it a max tokens of 200. Okay, so let's see what we get back here. This is using the default temperature value of 1. Once upon a time, there's a brave knight who lived in a faraway kingdom. His name was Sir Andrew. Okay, it seems like a pretty cohesive, sensical story. It makes sense. Now, if I increase the temperature here, and I go way up, so the absolute maximum is 2. If I go to 2, we're probably going to get something that makes no sense. If it ever responds. Here we are. Once upon a time in a faraway possibility and faraway land, atop the magic Pinnacle Castle lives upon Camelot Lady Madad something Winazad forever. I mean, you can see these aren't even words really, right? And it just kind of loses the plot entirely. So that is with a maximum temperature. The absolute max possible is 2. Once you go above 1, you start to get some weird nonsensical stuff. So I don't recommend that. And the docs don't really talk about this. They just say you can go from 0 to 2 and the default is 1. But it's telling that if you use the playground here on the documentation, temperature won't actually go above 1. It goes from 0 to 1. And you don't have a choice. You can't use 2. If I try and type that in here, it just ignores it. So you can go up to 2, but generally you get really weird results if you go above 1. So let's try decreasing this. Let's also just do 100 for the max tokens. If we go to 0 for our temperature, we'll get a pretty basic story that should make a lot of sense and be pretty straightforward. Now, this is not exactly the best illustration of temperature. I think it's easier if I show something where we're just asking for, let's say, a single word or two, like my favorite animal is a, and then we'll hit space. And if temperature is 0, it gives me dogs. Favorite animal is a dog. Dogs are loyal, loving, and make great companions. So it keeps going on about dogs. If I repeat this, still with temperature of 0, pretty much the same exact response. Dog. Dogs are loyal, loving, and make great companions. Do it again. Same exact response. At least I'm not looking at the second and third lines, but pretty much the same. Loyal, loving, great companions. We all love dogs. Okay. Now, if I increase its temperature maybe to 0.7, and I try it again, this time it gives us monkey. Monkeys are intelligent and curious animals. Let's run it again. This time it goes for dog. Run it again. Okay, we're back to dog. Dog. But you can already, the fact that we got monkey is slightly more random or creative. So dog is almost certainly the most probable next choice to complete this here. But when we increase that temperature, right, the curve of those probabilities changes. And so now maybe it looks something like this, where this is dog and this is monkey. And that's a vast simplification because it doesn't really work with words at a time, right? It's working with tokens. But still, you can kind of visualize this curve is changing. And now it's getting hung up because I probably hit a rate limit. We'll see. Okay, I had to time it out, or I had to interrupt it because it was just getting hung up. Now let's try something above 1, which again, generally is kind of risky. And this time we get tiger. It's more creative, although that term creativity implies, I think, some more agency to what's actually happening, right? It's all just probabilities, and we're shifting those probabilities by changing the temperature. So the resulting output might be more creative, or you might just call it more random. But I think that term creativity, implies a bit more consciousness or agency behind it. Okay, so I have a quick demo here. This function called nicePrint expects a dictionary. And what it will do is for every element in that dictionary, it's going to basically print out a nice formatted output where it's just easier to look at. So here is me calling this nicePrint function with a dictionary. And what I'm doing here is making an API call, basically, openai.completion.create, where the prompt is my favorite food is, and I'm setting the temperature dynamically because I actually have a loop here. So temperature will be 0, and then 0.5, then 1, then 1.5, then 2. So you probably wouldn't ever do this in the real world, but just to show you how this works and how temperature changes the output, I'm running this API call, 5 different times with 5 different temperatures. And I do need to import something called TextWrap to make this work. Okay, So this function up top has nothing to do with OpenAI. It's just to help us format the output. So now when I run this, depending on if we're going to hit a rate limit problem for making these 5 queries in a row, we'll see. Okay, it took a moment, but it finished up. We have our output. You can see it's just formatted. I used text wrap, this thing up top that we imported, so that it can be displayed nicely. You don't have to scroll over to the left or to the right to view it all. But we can see our first response with temperature of 0. My favorite food is pizza. I love the combination of the doughy crust, blah, 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 blah. Then we increase temperature a bit. Our favorite food is still pizza, but we get a little bit different output towards the end. I also like to try different kinds of pizza, like deep dish, thin crust, and stuffed crust. Pizza is a great meal that's easy to make, and then we just hit the cutoff for our max tokens. We keep going up. Temperature is now 1. Favorite food is still pizza, and we're probably not going to see much of a difference in terms of the language. Technically, all of this language here is supposed to be, it has a higher temperature, so each token itself, right, the probability of each token is altered by increasing the temperature, but it still is readable and makes sense. And 1 is about the threshold where most people recommend you don't go above, because as soon as we get to something like 1.5, well, our favorite food has changed to burgers, which, okay, fair enough. Burgers are decent. But we have some weird stuff going in as we go down the page. I mean, what is this here? Brought manufacturers of mass, one word, of mass produced burgers cannot show space capital A apart. Making chow mons with assorted beans. And then all the way at temperature of 2. Steamed crab, steamed king crab, somebody's favorite food, but then the language just doesn't even make sense. Like hatu turted Witzer mole of a carved debris. Okay, so you can clearly see that the language basically deteriorates as we increase the temperature, and generally sticking between 0 and 1 is a good plan. 0 is going to be the greatest chance of being deterministic, meaning that you'll get the same response every time, although it's still not guaranteed. And then increasing that temperature is going to change the probability curve for each new possible token that the model will choose from. And by doing that, it increases that randomness, because now it could pick burger, pizza, steamed king crab, versus here, it's almost always going to pick that most probable token, which was going to be pizza in our example. So that's the concept of temperature. You can play with it, and that's generally what I do. Start with the default temperature, and then if I'm not happy with the results I'm getting, I can tweak it. Next up, we have a second parameter we can provide called top P. And top P is kind of similar to temperature in that the end result of changing top P is that we can alter the creativity or randomness of the output. But the mechanism behind it is different. So the first thing you should know is that top P varies from 0 to 1. Temperature can go from 0 to 2, but as we saw, if you go above 1, you can get some wonky results. So generally, people will set temperature between 0 and 1. With top P, you don't have a choice. It only goes from 0 to 1. So when we change top P, what's happening behind the scenes is that there's an alternative mechanism to sampling tokens. Instead of using temperature, it uses something called nucleus sampling, although you can actually use temperature and top P at the same time, but we'll ignore that for the moment. And the way that this nucleus sampling works is that when the model has this set of probabilities generated for the next possible token, right, where there's probabilities generated for every possible next token in a sequence to build that output, they're each assigned a probability. So this is a very simplified version. Imagine there's only 5 choices of tokens, and let's actually call them words instead of tokens. So this is favorite food. And the next choice, so my favorite food is, let's say the most likely is pizza, and then burgers, and then enchiladas, and then steamed king crab, and then something else down here. When we change top P, what we're doing is not actually changing those probabilities in any way. It doesn't mean we're more likely to pick a lower probability token. When I say we, I mean the model. Instead, by changing top P, we are shrinking the window or growing the window of candidate tokens that we will allow the model to choose from. And the way that it works is when we set this top P, let's say to be 0.2, we're restricting the candidate words, technically tokens, but we'll call them words, to the smallest set whose cumulative probability is greater than or equal to this given threshold called P, meaning that we're shrinking the window down or expanding the window of possible choices. It's not changing the probabilities themselves, they're still the same, but we're basically throwing out, in this case, this token and this token and this token. If top P is 0.2, 20%, then again, very simplified explanation, but we have a 14% token and a 6% probability token. They, are the two choices that it would pick from. With top P set to 1, it could pick from all of these, any token at all, not just these 5, but any token that exists in the whole model. So we're shrinking that window down, but we're not changing the probabilities. Top P of 1 just means you're free to pick from any token. Top P of 0.1 or 0.0001 is going to create a smaller window of possible choices that we'll allow. So I have a demo for this. The end result, by the way, is that by increasing top P, we get more choices, right? More possibility of random or creative output for each individual token. And by shrinking top P down, we'll get closer to a deterministic output. Just like with temperature, a higher temperature means more randomness, a lower temperature means more deterministic results, but the mechanism is different. So I have a new notebook, just the basic setup, get my API key in there, and then I have this function nicePrint that we saw in the previous video. And I'm going to call nicePrint where I'm looping, right, for each top P. So I'm doing 3 different calls, top P of 1, 0.5, and 0. I'm passing that through. And the prompt is my favorite food is, and then we ask it to complete it. We wait with bated breath. We hope it works. Okay. So in this case, it looks like pizza is the answer for all of them. Pizza, pizza, pizza. Now, the output is slightly different as far as the rest of the paragraph that we get, but let's just focus on that word pizza. Let's run it again. So it seems like pizza is clearly the most probable next word, right? Technically, I don't know if it's a single token or not, but let's just say this is a token. That's the most probable next choice, and we keep getting pizza, 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 regardless of what top P is. But eventually, for the one that has top P of 1 at least, there we go, it's likely to get something else because we're allowing a bigger window of possible choices. So it picked sushi this time, whereas it's still doing pizza and pizza for top P of 0.5 and top P of 0. So when it comes to comparing top P and temperature, they both can work in a similar way. They'll change the randomness / creativity of the output, but they work in a different mechanism. So temperature essentially changes the probabilities that are generated. So you can think of, this diagram here, where the curve of probabilities for the next possible token is going to be shaped completely differently depending on temperature. It's actually changing the probabilities and making some tokens that may have been less likely a lot more likely when you increase that temperature. Whereas top P is not changing those initial probabilities, but instead it's setting a sampling window that dictates which tokens are allowed to be chosen and which ones are not allowed to be chosen. But the probabilities are still the same. We're just making a window to restrict or increase the size of that sample set that we're picking from, or that the model is picking from. So both of them can increase this randomness, but they do it in a different way. Now the documentation recommends that you only use one or the other, temperature or top P, but for a demonstration's sake, I'm going to combine the two. So here I've set temperature to 2, which is the maximum, the pure weirdest possible results we can get. And then I've set top P dynamically to be 1, 0.75, 0.5, 0.25, and 0. And when I run this, the prompt is still my favorite food is. Here's our result. So starting at the bottom with the lowest top P possible, my favorite food is pizza. So it's pretty clear by now that pizza is the most likely completion. I'll call it a token, but it may be more than one token, but it's the most likely word to be completed for my favorite food is. So when we set top P to 0, we're severely restricting that window, right, of the possible tokens. So we're pretty much always going to get pizza. When we increase it a slight bit more, we're still getting pizza, and then all the way at 1, I got salmon sushi. So the language in this example is also just kind of crazy. Again, that's likely because our temperature is so high. But let me run it one more time, and we'll probably get a lot of pizzas again. But then for the higher top P's, 1 and maybe 0.75, we may get something different. Okay, well, pizza, 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 pizza. And then for a top P of 1, my favorite food is no wall cups. Nachos in brackets. Interesting. So this is what happens when we combine temperature and top P. But by increasing that temperature, it makes it more likely for us to choose something slightly different. So it just makes it easier for me to show this example. So I'll do it one more time, and we'll probably get a third different result for this top P of 1. So temperature is impacting the probabilities, and then top P is impacting within that set of all the probable tokens, which ones are we allowed to pick from? And here we go a third time. Pizza, 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 and then top P of 1. This time we got French fries. So it's not something that is all that easy to illustrate, because a lot of the time we'll just get the same exact answers over and over. But by increasing top P or increasing temperature, the docs recommend you only do one, but as I just showed, you can do both. We can increase the randomness and the chance that we'll get something different. By decreasing top P or decreasing temperature all the way down to something like 0, we can get as close to a deterministic output as possible. It's not guaranteed to be the same every time, but it's likely to be. So those two parameters are similar, but the mechanism behind them is different. And in general, I would pick one or the other. I tend to start with temperature to see if I can spice things up, and then play around with top P if I'm not happy with what's happening with temperature. Welcome back. So next up, we're going to talk about two different parameters we can provide that sound similar. One is called frequency penalty. The other is called presence penalty. They both have to do with reducing or increasing repetition in our output, but the way they do it is different. So we'll start with frequency penalty. It's a number ranging from -2 to +2. It defaults to 0. And if you set it to be a positive value, like 1, or even something extreme like 2, that will penalize any new tokens based on if they already occurred in the previous output so far. Basically, the more often a token has been generated in your output, the higher the penalty on that token will be, discouraging it from being generated again. And then if you decrease the penalty and you make it negative, you're basically encouraging repetition. And the overall idea here is that we can set it to a positive value to decrease the model's likelihood to repeat itself. So we won't get the same line over and over and over again. Not that we've been getting that anyway, but you can tweak it to change the repetition. So let me show you an example just in a new notebook. I've done all the basic setup, API key. I'm using that nice print function that we've been using for a couple of videos. And what I'm doing here is another dictionary comprehension where for each one of these values, -2, -1, 0, 1, and 2, I am creating a new completion and then printing out the result. But for each completion, frequency penalty is set to -2, -1, 0, 1, and 2. And the prompt is the first 15 elements are hydrogen, comma, helium, comma, and let's hope it works. Sometimes this times out on me for making too many requests at once. Let's see. Okay, so it did work. Now, let's go to the far extreme at the beginning. -2 for frequency penalty basically encourages the reuse of tokens. The more a token has occurred, the more likely it is that it will continue to occur. So it's this additive effect. Now, we can talk about the math in a separate video, but think of it this way. Just count up how many times this occurs. It occurs once. Oh, it occurs twice. Now it's twice as more likely to occur. It occurred 3 times. It doesn't work that way. It's not necessarily linear, but there is an equation behind the scenes that means tokens that have already been generated in the output are more likely to occur when I set frequency penalty to be negative. And the more that they occur, the further more likely they are to be generated. And then you can see with -1, it's a similar result, right? We get tons of commas because they occurred over and over and over. And right now we have a negative penalty, meaning we're encouraging the repetition. Here's a frequency penalty of 0. So there is no penalty really going on at all for tokens that have already been generated. And we get the first 15 elements on the table, the periodic table. But then as I increase the frequency penalty all the way up to 2, you'll see that eventually it stops putting commas in here, right? Magnesium, aluminum, silicon, phosphorus, sulfur, it starts to penalize the comma. And at that point, we no longer get commas. Now, does it really make sense to have a frequency penalty this high where it starts ignoring the rules of grammar? No. But it can be useful, as we talked about, to decrease the likelihood of repeating the same line verbatim. So we can get new content. It's less useful if you're trying to get it to stop using a particular character or token. If that was the case, in your prompt, you could just say, do not use commas, or avoid using the word hydrogen in your response, right? We can give it special constraints in the prompt itself. This just illustrates how it works. This is not a use case where I would recommend using frequency penalty if you really don't want commas in there, because it still gives us commas at the beginning, but then the penalty builds up the more that the comma has been generated. So a rough guideline here is if you just want to generally reduce repetitive outputs, try a penalty ranging from 0.1 to 1 and start small and increase, but I don't recommend going above 1. And then the docs say that if you really want to suppress repetition, you can go above 1, but it can lead to bad quality outputs, which we just saw, right? When we had a frequency penalty of 2, it ignored the rules of grammar and stopped putting commas in there. And then as we also saw, negative values will increase the likelihood of repetition. And an extreme negative value like -2, it starts repeating commas all over the place. And that's just because commas happen to occur a lot in this example. And the more they occur, the more likely they are to continue to be generated. So that's frequency penalty. If you go to the playground, you can play with them too if it's easier just to visualize here, although it won't let you go negative. So I can only do 0 to 2. I usually just leave it at 0. And then if I notice I'm getting some repetition, I wanted to try, talking about something new. And it comes up more, I'd say, with chat situations for me. But if I want it to stop repeating itself, then I can try increasing frequency penalty. We won't really notice much of a difference, though, if I just try saying, tell me about surfing. Give me, how about 10 sentences. I'll start with frequency penalty set to 0. Okay, so it gives me 10 sentences, and I'm just going to cut this out because if I try and regenerate this while it already gave me an answer, it won't regenerate. So now I'm going to try it again with a much higher frequency penalty. Okay, and if we compare the two, here's the first answer. If we take a look at just a single word like surfing, it shows up here, it shows up again, it shows up again, it shows up here, it shows up there, it shows up there. It uses the word surfing. Now, it works at a token level, not a word level, but we'll use those terms interchangeably just to simplify explanations here. Now, if we look at this second example, looks like it ran out of, did it run out of? Yes, I gave it a max length of 256. Anyway, we have surfing and then surfing again. But then I don't think it ever uses the term surfing anymore. And if I try this and I give it a larger sample, let's say 15 sentences and a larger maximum length with still a very high frequency penalty, much higher than you probably would ever want to go, it starts getting kind of bizarre towards the end. Looks like it's starting to penalize, is it the period? So the new line character is probably what's being penalized, actually. I don't know. I usually say penalized. I don't know why I'm saying penalized. But so it stops putting those new line characters in there. and we just get this massive chunk of text. You'll also see, the word surfing doesn't occur, and other things, other tokens that have been generated previously are going to be way less likely to occur towards the end of this output. But it starts causing problems because the formatting gets messed up. There's new line characters, like right here, there's a new line character. Right here, there's a new line character. After each one of these, there's a new line until eventually that penalty gets so great that it stops generating new line characters. So that might be too extreme. But if we come back and adjust this to something more like, between 1, I don't know, how about just let's do 1. That's about the extreme of where we want to go. Let's see. Oh dear, it's timing out for me. We'll see if I might need to refresh the page. Okay, we'll try that again. Frequency penalty will go up to 1. And I'll increase my maximum length just so it doesn't run out. Try this again. So we'll see if it runs into the same problem with the new line characters. It seems okay so far, although, nope, same problem. So 1 is still too high, right, if we care about this formatting. So we'll probably adjust this even further down, maybe 0.6. And honestly, you don't need to keep watching me do this. I just want to show, an illustration of how it actually makes an impact. And the longer your sample is, the easier it is to see that impact. Okay, so it looks like our format is still preserved, right? We're still getting the lines, the numbered lines, but this is still theoretically reducing repetition. But it's still at a natural way where it's not actually warping our output, which if you go above 1, and certainly if you go close to 2, it will. And then if I had a negative value, it actually is incentivizing, right? It wants repetition, which most of the time I wouldn't do, but you can, just not in the playground. You have to do it via the API. So next up, we have another penalty. It is the presence penalty. And if I read through the description, it's going to sound very similar to the frequency penalty. It's a number ranging from -2 to 2. It defaults to 0, and it will penalize, however it's supposed to be pronounced, new tokens based on whether they appear in the text so far, increasing the model's likelihood to talk about new topics. That sounds just like frequency penalty, right? If we go back, frequency penalty will penalize new tokens based on their existing frequency in the text so far, decreasing the likelihood that the model will repeat the same line verbatim. But there's a difference in how they're implemented behind the scenes. Presence penalty is a one-off additive contribution. It's a one-off penalty that says if this token has already occurred, then penalize it. Frequency penalty is proportional to how many times a token has already been created or sampled in the output. So the more often something occurs, the more penalized it will be with frequency penalty. That is not true with presence penalty. It's a one-off contribution. So if a token occurs once or if it occurs 10 times, it's penalized the same. With frequency penalty, that is not the case. It's proportional to how often it has already been generated. So effectively, this means presence penalty at a really high value compared to frequency penalty, let's say 2 for each of them, the maximum, is a lot more severe for frequency penalty. So with our surfing example, if you remember in the playground in the previous video, I set frequency penalty way high up, and let's maybe just do 10 sentences. It eventually was penalizing the new line character. And so we weren't getting new lines like you see right here. And this is with frequency penalty maxed out at 2. Now, if I turn that off and instead regenerate it with presence penalty, it still will penalize characters, or rather tokens, that have previously been generated, but it doesn't have this additive effect. So it shouldn't penalize our new line character so much that we stop getting new line characters. It has a much more subtle effect where generally frequency penalty is used to reduce the actual duplication or repetition of sentences and of things, words, tokens verbatim. Presence penalty will steer the output to generally include new topics. So if I tried rerunning this query here that we ran earlier with frequency penalty, where we asked it to generate the first 15 elements, or the first 15 elements are hydrogen, comma, helium, comma. With frequency penalty, we saw that it eventually stopped using commas, because the more that token appeared, which the comma itself is probably not a token, but basically the effect, we can think of it as the more a comma occurred, the less likely it was to occur later on in the output, and so we end up with no commas towards the end. But if I do this with presence penalty instead of frequency, same concept though, I'm running at -2, -1, 0, 1, and 2, all for presence penalty. Everything else is identical. Here we go. I changed the text, by the way, to say presence penalty just in the output. That doesn't have any impact, of course, on the actual query. If we look here, this is the highest possible presence penalty. We still have commas, right? We don't really get anything different between these, really any of them, because it's a flat penalty. It just says, all right, let's pretend this is a token here, or the comma is a token. It's already occurred. Let's just penalize it a flat amount throughout the rest of this output. Whereas frequency penalty, that significant difference is that it will penalize it more the more often a character or a token has already been generated as part of the output. So eventually it stops generating commas. So anytime you go above 1, for either of these penalties, the results can get a little bit weird. Especially with frequency penalty, you can get results that are not grammatically correct. So the advice, as I showed previously, is to stay somewhere between 0.1 and 1 generally. And then the difference between them, aside from how they actually work, is that presence penalty will increase the likelihood that the model's output will talk about new topics. Frequency penalty will decrease the likelihood of repeating the same line verbatim. Both are penalties, but they have slightly different impacts. Next up, we have another parameter that we can use when making a request to the completion endpoint, which is called stream. Stream is a Boolean value. It's true or false. It starts, or it defaults to false. So everything we've done so far, we've had it false because we've never explicitly set it to true. But if we do set it to true, it will stream back partial progress. Tokens will be sent as data-only server-sent events as they become available. Basically, as the data is generated in the output, it will be sent to us in small pieces as those tokens become available. Instead of the normal approach, which is the whole output is generated, and then we get that response. So I have a new document. I'm just calling it stream. I've imported OpenAI. I've given it the everything I need to set up my API key. And if I do a simple completion, OpenAI.completion.create, and let's do something like, first the model will be text DaVinci 003. But then after that, I'll set the prompts to be, how about write me a poem about, I don't know, what do we want a poem about? Foggy morning commutes. Okay, so if I run this, it takes some time, and then I get the full response back when it's done. Oh, by the way, I should probably increase max tokens, maybe to like 300. So it will write the whole poem, generate the full output, and then respond back with that eventually, although it seems to be taking longer than it should. And there it is. Okay, so it generated the whole output, and then it sends that back to me. But if instead I set stream to true, this does something very different. Now we won't see the output by default because now in Python, this returns something called a generator. Now, if you've never used generators, it's not a big deal. Basically, I can iterate over this object, and that's exactly what I'm going to do. So I'm going to do something like for data in OpenAI completion create. This is the generator, so this is just a variable name. I could do X. I'm going to call it data. For each one, what I'm going to do is print out data. And if I just print the data and I run this, It's kind of a lot to look at here because data is the full object we get back each time. So what I really want is choices and then text. And it looks like our first token, the first thing we got back is a new line character. And then what else did we get back? The. And then after that, we got city. So we get all these individual pieces of data sent as they're generated. But instead of printing them like this, let's at least refine it. So it's print data.choices of 0, right? So here's one piece of data. We want choices, the 0th element, and I want .text. Okay, and it's hard to see. There we are. If I go down to the bottom, well, we missed it, but the data was coming in one bit at a time and being printed as it comes in. But what's making it extra hard is that print by default is on a new line every single time. It separates each print with a new line. But there's an argument to print in Python called end. And if I specify something else, like just an empty string, this is what it appends to the end of every print instead of a new line. And now if I run it, take a look at what we get. It's building up our response one piece at a time. So let me run it one more time. You can see pieces of data, basically a line at a time, being added in. That's actually not how our data is being sent to us. It is not coming in one line at a time. What's happening is when I'm printing it out, basically the shell is going to normally buffer its output. It will accumulate some text and then periodically dump it to the screen. I can change that behavior by setting a parameter or an argument called flush to true when I'm printing. And this basically says, all right, every time you get text, immediately render it. Don't group output, don't accumulate the text. And now if I run this, take a look. It looks like someone's basically typing very quick. We're printing out immediately every time we get a new piece of data from this generator, right, which is being sent a stream of information based upon this prompt as the model generates the output. It sends it back to me, and then I'm printing it out. This is just to get rid of the new lines between each piece. And this is to tell print to stop grouping and accumulating text and instead immediately print it out as soon as it gets text, just so we can see it. So there's, in the real world, you're probably not going to be printing stuff like this. I mean, maybe if you're making a chatbot in the command line or something, for example, but you would probably do something else to the data as it streams in. The point is, by setting stream to true, it enables that streaming behavior, where the server sends us data as it has it, as it generates the information. It sends it to us, and then we can do something with each piece of data as we get it. In this case, I'm just printing it. Nothing that exciting. But it's at least an illustration of the fact that our data is coming in small chunks. And you can see that happening right there. So if you set stream to false, or you just leave it off entirely, which is the default of false, the API will wait, send us the full output once it's generated, basically one response. Whereas if we set stream to true, the server will send us data as it generates it. And then you have to be set up to handle that. In this case, we're printing it. You do whatever you want, but you have to be expecting that because you handle it differently if you're just getting back a single response versus, like in Python, it's a generator. But depending on the language that you're using, like in JavaScript, if you're trying to use, I think the Node library supports it now. It didn't for a while. So anyway, you have to be careful about what you're using and how you're handling the data coming back. But that's the stream parameter.